mean about, I would never say anything mean about 5th hour or 1st hour, but 4th hour. Now that's just an all-around awful class. What is, yeah, exactly. Especially 4th hour. Especially some of the people in 4th hour. Names which I won't state, but they are all of the female gender. Oh, well that doesn't make you guys feel very, you know what they said today? They said, girls go to college to get more knowledge. Guys go to Jupiter to get more stupider. I've never heard that before. And that, no, I hadn't. That was so immature. So anyway, 4th hour, you're horrible. And as soon as one of you watches a video where you can tell how horrible I told you were, I will reward you with a candy bar. Because that's my motivation. See if you actually watch these things. Apparently, none of you do. So, let's get to this. We will do the radiator problem. And here we go. Now we're off. So it starts like this. There's a radiator. And radiators are for this one purpose. They are cooling mechanisms. Okay? So, do your hands dry faster if you have a puddle of water in your hands or if the water's all spread out? All spread out. So, radiator does the same thing. Radiator allows the fluid to flow back and forth in thin amounts so that it will cool quicker. And then that cooled fluid then flows through your engine. It gets warm. It travels back through your radiator. It cools down. And so there's two components to the type of fluid that you put in your radiator. Number one is antifreeze. And in this problem, the radiator is filled 60% with antifreeze. Antifreeze is dangerous. It doesn't allow things to freeze, and it maintains a cooler temperature. It tastes really sweet. And I haven't tasted it, but it is something that people have actually used to lace like drinks, like say pop or Gatorade. They'll lace it with this to cause people to get sick. And actually, people, I watched a movie, not a movie, I watched a real crimes TV show where the wife killed the husband by, no, it was the other way around. The husband killed the wife, lacing the drinks with antifreeze. So don't want to do it. I'm not condoning this behavior. I had a friend who put antifreeze in their toilet at their cabin up north because that way it wouldn't freeze. But the dog got to the toilet. Was dead in a day. Yeah, sad story. So beware of the antifreeze. Don't leave it sitting out in the garage. People, it kind of has that yellowish look to it. People think it's like fun to drink. No, naughty. Naughty. Well, what do you think I thought when my daughter was walking around with a case of antifreeze out of my garage? Exactly. Fortunately, it was only water, and she hadn't tried to drink it yet, but she was setting up for a picnic. So, you got to be careful. 60% antifreeze, 40% water. Now, every radiator has what we call a frost plug, and that plug is so that if you want to drain it, you can. And so what they want to do is this. It currently has 3.6 liters of fluid, and it wants to drain some fluid out and then put just water back in so that it will reduce it from 60% antifreeze to 50-50. Everybody knows that the optimal amount is 50-50. If you go to buy antifreeze, you can buy just straight 100% antifreeze, or you can buy already mixed at 50-50. It costs the same. What should you do? No, you buy the 100% straight stuff and then mix it yourself and get two for the price of one. So, that's what you do. So we want to drain it to get 50%. That's what we want. We want 50-50. So, let's work this out. I'm going to drain. There it goes. Do we know how much we take out? No. That's what we're trying to find out. We're going to drain X amount. True or false? When I drain fluid from the frost plug, some of that fluid is water. True. How much is water? Yeah, 0.4x is going to be water. True or false? When I drain it, I'm going to have some antifreeze coming out. How much? 0.6x. After I drain X amount out, how much do I put back in? X. If you drain 1 liter, you have to put 1 liter back. If you drain 2 liters, you have to put 2 liters back. So we're going to put X back. If we want the amount of antifreeze to go down, and we want the amount of water to go up, do you think we put straight antifreeze in? No, that would be stupid. Do you think we put straight water in? Yeah, that would be a good idea. We don't want to. Yeah, we don't want to make it too complicated. We just put straight water in. So what we put in is 100% water. That's what we're going to put right back in. 100% water, or 1x. And so that's kind of the diagram of what's happening here. So now let's set it up. Percent of antifreeze. If you want to know the percent of antifreeze that's going to be, end up at the end, you want the amount of antifreeze divided by the total amount. If you want the percent of water, you would need to take the amount of water and divide it by the total. Fourth hour could get a candy bar if they just watch a video and let me know it. All right, so which one do you use? We got 2 equations. There's one that's optimal, one that's better to use. Which one do you think? Do you think we use the antifreeze one or the water one? Why? That's what we're putting back in. So we're going to use this one. Percent of water. What is the end result for water that you want? What percent? 50%. So you can either write 0.5, 1 over 2, 50 over 100. Doesn't matter. I'm going to write 1 over 2. We want 1 over 2. Equals. Let's start with the bottom. How much stuff do you currently have in there? 3.6. But I'm draining some of it out, right? How much are you draining out? X. So minus X. But I'm putting stuff back in. How much am I putting back in? Plus X. The total amount. Does it care that some of this is antifreeze and water, whereas this is just straight water? For the total amount, does it care? No, it doesn't care. It just says you took X out, you put X back in. I don't care what it is. I just want to know the total amount. But on top, we want the amount of water. Ooh, well, that's different. If 40% of it is currently water, how much do I have from the start before I even drain it? 40% of it is 1.44. Very good. God, I wish I was as smart as Preston. At least I'm better looking. Hey! No bald jokes. That's okay. You should see my daughter after I buzzed my hair this summer. She came up to me and she is Kiara, 8 years old, and she, not joking around, very serious. Daddy, why would you do that to your hair? Now you can see your bald spot in back even more than before. Well, Kiera, I said, this is just kind of the inevitable. If I didn't have to do it this year, it would have been in 2 years, 3 years, 4 years. She's like, I don't get it. It's like, why do you guys have to lose your hair? And I said, well, that's just something that happens. And then she wanted to know if she was going to lose her hair and stuff like that. I told her, I said, Kiera, last time I was at Walmart and I was going through a checkout. And one of the ladies was losing a lot of her hair, like more than I had. I said, if I got to take one for the team and lose my hair, I think it's easier for a guy to lose their hair than a girl, right? So I'll take one for the team. Now, Preston, do you know your grandpa on your mom's side? Does he have a full head of hair? You don't know? So it's a recessive trait that passes through your mother's side. So it doesn't guarantee that you're going to go bald, but if your grandpa on your mom's side, that's what you got to think about. So guys, that's where you got to look. All right. Okay, so we got amount of water. We currently have 1.44 liters of water. What's an expression for how much water we're draining? Not X, but 0.4X. You're draining X out, 0.4 or 40% of which is water. How much are you putting back in? X. What percent of that X is water? 100%. Do you see where all those numbers came from? 50% mixture with water. 3.6, the total amount. I drain out X, I put X back in. 40% of it's currently water, 1.44. I drain out 40% water, I put back in 100% water. There it is. It's easy to solve. That's my equation. That's all there is. 1 over 2 equals 1.44. What's 0.4x plus 1x? 0.6x. Divided by, see the x's, they go away because you end up with the same amount. So you got 36. Cross multiply. Oh, 3.6. 3.6 is equal to 2.88 plus 1.2x. Subtract 2.88, you got 0.72 is equal to 1.2x. Divide by 1.2. 0.6 is x. So, if you encounter this type of problem, you drain 0.6 out to reduce it to 3 liters. Then you dump 0.6 of straight water back in, and you arrive at exactly a 50-50 mixture. Yep, 0.6 liters. And that's it. So, raise your hand if you're able to start at least one of the problems from your homework last night. Ooh, wow, only 2. You were able to start 1 or 2 of the inequality problems last night. So we got a couple. Okay. Oh, you did them all? Good. So I just add 2 to it. What did I assign? 39, 40, and 41? So then I watch you 42, 43. That's it. Same stuff. That's all there is. Tomorrow we go over absolute values and we'll be done with 1.7. Yes, you may.